All right, this is our last example for this lesson, and it is a situation where we have a matched pairs experiment. So let's look at what the question is. Researchers designed an experiment to study the effects of caffeine withdrawal. They recruited 11 volunteers who were diagnosed as being caffeine dependent to serve as subjects. Each subject was barred from coffee, cola, and other substances with caffeine for the duration of the experiment. During one 2-day period, subjects took capsules containing their normal caffeine intake. During another 2-day period, they took placebo capsules. The order in which the subjects took caffeine and the placebo were randomized. At the end of each 2-day period, a test for depression was given to all 11 subjects. Researchers wanted to know whether being deprived of caffeine would lead to an increase in depression. And so this is from the textbook, not page 633, but rather page 578. Now, the table below shows the participants' scores for depression and caffeine, and we are going to, in this column, write the difference, and we're going to do caffeine minus placebo. And I used the lists. I entered caffeine into list 1, placebo into list 2, and the difference I did L1 minus L2, and these are the values I got. So you should try doing the same with your calculator to make sure that you're getting the same results as I am. So you'll notice that these are all different, and sorry, just a minute. You'll note this one is positive. If caffeine made a difference to depression, oops, only one P there. If it made a difference, in other words, an improvement, the difference would be negative. Less than 0. So note that this is a matched pairs experimental design. Each participant acts as their own control. And so in this case, we're taking a difference, but we're not taking a difference of the average of each group. We're taking the difference for each individual. So that's what how a matched pairs works. So at this stage, what statistics will you use to determine whether there is a difference in depression levels? So we are going to use a paired t-test. For the average difference if conditions are met. And because we have 11 subjects, we have 10 degrees of freedom. And since the significance level is not given, we will use a significance level of 0.05, since significance level not stated. Okay, so the difference in the depression scores we're going to calculate as we've done already, and then use what just cross that out. So H naught is 0, that there is no difference, that caffeine has no effect on depression. And HA is that the difference is less than 0. In other words, that caffeine does have an effect. So you'll note here that we're only interested in caffeine having a positive effect, not a negative effect. So this gives us a paired t-test. So once again, we need to check our conditions when we're using a t-test. So that's RIN, random. And in this case, the treatment was randomly assigned. Who got assigned first and who got assigned second. It was independent. We aren't sampling. This is an experiment. So we do not need to check the 10% condition. But we do need to assume that each person's response to treatment and depression scores are independent. And of course, that is a reasonable assumption. Okay, and finally, the normal condition. This population is not normal. N is less than 30. So therefore, we cannot use the CLT. N is less than 15. So we must examine the data for skewness and outliers.